Now, on the second objective in this module, we see how to design a security operation strategy. The first section is an overview of the key security operations tool in the Microsoft Cloud that you should know for the exam. You may know most of these security services already, especially if you have done the SC-200, SC-200, and the AZ-500 exam. We will dive later deep in each one, but for now, you'll get a quick introduction of these key security tools. Just a quick refresher here. The first one, Azure Monitor. This event logs from application and Azure services. Azure Monitors gives you application monitoring data about the performance and functionality of code, regardless of its platform. Guest OS monitoring data about the operating system that is running. Azure resource monitoring data about the operation of an Azure resource. Azure subscription monitoring data about the operation of management of an Azure subscription, and data about the health and operation of Azure itself. We have also the Azure tenant monitoring data about the operation of tenant-level Azure services, such as Azure Active Directory. Next, we have the log analytics. A log analytics workspace is a unique environment for log data from Azure Monitor and other Azure services, such as Microsoft Sentinel and Microsoft Defender for Cloud. You can use a single workspace to be used for all data collection, or also you can use multiple workspaces. Can also be created based on various requirements, such as the geographic location of the data for data residency, access rights that define which user can access data, and configuration settings such as the pricing tier and data retentions, where you can create multiple workspaces. Now, next we have the next tool, operation tool, network security groups, visibility into network activities. An Azure Network Security Group, or what's called NSG, is a layer 4. So the key point here, this is layer 4 that understands TCP, UDP ports, and IPs. It doesn't understand applications, HTTPS, nor FQDN, anything like that. So NSG can be used to filter network traffic to and from Azure resources in an Azure virtual network. And a network security group contains security rules that allow or deny inbound network traffic to or outbound network traffic from several types of Azure resources. 0 or 1 more network security group can be associated to each virtual network subnet and individual network interface in a virtual machine. The next one, we have Microsoft Sentinel, the security information and event management SIEM solution and security orchestration and automation response SOAR. Sentinel, it collects data at cloud scale across all users, devices. It can collect from anywhere, application, infrastructure, both on-premises and in multi-clouds. It detects threats and minimizes false positives using Microsoft Analytics and unparalleled threat intelligence. You can investigate threats with AI, artificial intelligence, and you can hunt for suspicious activities at scale. You can respond to incidents with built-in orchestration and automation rules of common repetitive tasks. Next, we move to Defender for Cloud Apps. This is what's called the Cloud Access Security Broker, CASB, that supports various deployment models. For example, in CCSP earlier, they mentioned the Cloud Access Security Broker, CASB, but of course, they will not here in Microsoft context. We have the Microsoft Defender for Cloud for CASB that support various deployment tools, including log collection, API connectors, and reverse proxy. It provides rich visibility to control over data travels and sophisticated analytics to identify and combat cyber threats across your Microsoft and third-party cloud services. It will be best to have Defender for Cloud to better understand the overall cloud posture across your SaaS software service application. And such, you can also discover shadow IT. It's very important to discover shadow IT. Defender for Cloud help you to do that. And of course, application governance are the key use cases. There are many ways for malicious actors to leverage cloud apps to get into enterprise networks and exfiltrate sensitive business data. In that case, the CASB will mostly likely be needed to address the additional unique challenges of regulating and securing the environment. This is Defender for Cloud. We have also the Azure Automation, which provides a way to automate the manual, long-running, frequently repeated tasks that you perform in the cloud, and also on-premise environments. So Azure Automation could be used for the cloud, also in multi-cloud or on-premises. You first need to create an automation account, which saves time to increase the repetitive task. You can even schedule these tasks to be automatically performed at regular intervals, and you can create runbook with PowerShell or Python as a runbook type. Next security tool in the business continuity disaster recovery, we have the Azure Backup and Azure Site Recovery. We mentioned this before. Azure Backup is the Azure-based service that you can use to back up and restore your data in the Microsoft Cloud. You can replace existing on-premises or off-site backup solution with cloud-based solution that is reliable, secure, and cost competitive. And Azure Backup offers a component to download and deploy the agent on the appropriate client machine or server on-premises or in other clouds. And Azure Site Recovery provides business continuity by orchestrating the replication of on-premises virtual and physical machines to Azure or a secondary site. And if the primary sites are unavailable, we can, of course, fail over to the secondary location so that users can keep working and the application is available. I'm actually currently in the middle of a project right now where we are building a disaster recovery site in Azure by replicating key business machines running on Azure Stack HCI to Azure. You can also replicate between different Azure regions, not only for on-premises. So if one Azure region goes down for any reason, we can also fail over to a secondary region with ASR. Now, last we have Active Directory, Azure Active Directory, and the Microsoft Defender for Cloud. We'll talk more about Azure AD security features, of course, later in the course. But here, a quick overview. Azure AD is Identity and Access Management cloud service. It provides central access management, single sign-on, reporting, MFA, identity protection, which is P2 feature, P2 license. It supports integrated access management for thousands of applications in the Azure Marketplace, including Salesforce, Google Apps, and much more. And the Microsoft Defender for Clouds, we'll talk more about it in this course, which is the Cloud Security Posture Management, CSPM, and the Cloud Workload Protection, CWPP. Microsoft Defender for Cloud helps prevent, detect, respond to threats with increased visibility into and control over the security of your Azure resources. It provides integrated security monitoring and policy management across all your subscription. And of course, it supports on-premises workloads in Azure and multi-cloud. Remember, multi-cloud, Defender for Cloud for Amazon AWS and Google GCP. Maybe you get a question in the other clouds for Defender for Cloud. Section 2. Now we know that what are the security operations tools that are available at our disposal. The next topic is about logging and auditing security strategy. As we all know, the cloud has dramatically changed the role of the operations team, and operations are still a critical part of running a successful cloud applications. So what are the types of logs that we have in Azure? As we know, the cloud application are complex because it has many moving parts around. And this diagram shows different components where the logs can come from and how you aggregate them into a single place with Microsoft Sentinel, for example, or another solution. And Azure logs are categorized into different types. We have the control management logs that provide information about Azure Resource Manager, the control plane, such as create, update, delete operations. Those all are logged, and they are known as Azure Activity Logs. We have the data plane logs, which provide information about events raised as part of the Azure resource usage. Example of this type of logs are the Windows Event Systems, security and application logs in a virtual machine, and the diagnostic logs for resources configured through the Azure Monitor. Some resources, such as the storage account, you can configure diagnostic logs to log the data plane management. Then we have the processed events, which provide information about the analyzed events and alerts. Example of this type are the Microsoft Defender for Cloud alerts, where Microsoft Defender for Cloud has processed and analyzed subscriptions and provide concise security alerts. This event. And logging data can provide insight about your application that can help you to troubleshoot past problems or even prevent potential ones, improve your application performance, and of course, automate action that would otherwise require manual intervention. Now, Microsoft Defender for Cloud threat protection includes what's called Fusion kill chain analysis, which automatically correlates alerts in your environment based on cyber kill chain analysis to help you better understand the full story of an attack campaign, where it started and what kind of impact it had on your resources. So this is, if you're in the security field, you already know the kill chain, the famous one. And Defender for Cloud and Sentinel, they support the kill chain intent, which are based on the MITRE ATT&CK framework. As illustrated here, the typical 8 steps that trace the stages of a cyber attack, it starts from the reconnaissance phase up to the exfiltration. We have the reconnaissance in the first stage, where attackers assess networks and services to identify possible targets and techniques to gain entry. Next, the attacker uses the knowledge gained in the reconnaissance phase to get access to a part of the network. This often involves exploring a flow or a security hole in your environment. Then we have the exploitation. This phase involves exploiting the vulnerability and inserting malicious code into the system to get more access. So here we're actually the blue team and the red team when it comes on to try to discover and exploit your vulnerability in the environment. Next, we have the privilege escalation. Attackers try to gain admin access to compromised systems to get access to more critical data and move into another connected systems on the network. And then comes the lateral movement stage, where this is the act of moving laterally to connected servers and gain greater access to potential data. Then we have the obfuscation anti-forensics, where attackers need to cover their trail to try to delete the logs, clear audit logs, to prevent detection by security teams. And then we have the denial of service. So this phase involves disrupting normal access for users and systems to keep the attack from being monitored, tracked, or blocked. And the final stage, extraction or exfiltration, is to get valuable data out of the compromised systems. Now, of course, different types of attacks are associated with each stage, targeting various different systems. Next, we look at designing a strategy for security information, event management, SIEM, and security orchestration, automation, and response, SOAR. Because this is a key of zero trust, is to assume breach. And an effective approach to assume breach means having a threat detection approach that provides visibility across the entire state, with the depth of information that security teams need to investigate individual threats. And by having the visibility, automation, orchestration, integration, we can, of course, build a robust solution for monitoring security signals. We can monitor source logs for insights on threats and mitigations. Here, the list of all security operation best practices for SIEM and SOAR to protect your data, application, and other assets in Azure. The best practices listed here are based on a consensus of, they work with current Azure platform and feature sets. So those are currently available in the platform, where you first receive incident notification from Microsoft. So you need to make sure that security operations teams receive Azure incident notification from Microsoft. And incident notification lets a security team know when there are compromised Azure resources, so they can quickly respond to and remediate potential security risks. And the Azure Enrollment Portal admin contact information includes details that notify security operations team. The contact information is an email address and phone number. So you need to make sure to have all details filled in. Then we have the monitor storage services for unexpected changes in behavior. Here you need to make sure to continuously monitor the storage service of your application that uses to see any unexpected changes in behavior. For example, Azure Storage Analytics performance logging and provides metrics data for an Azure Storage account. So you need to monitor those logs. Then we have to prevent, detect, and respond to threats. And the increase in speed and scalability of your SIEM solution, you need to use a cloud-native based SIEM. Microsoft Context is Microsoft Sentinel, cloud-native SIEM, instead of a legacy SIEM solution. And you can integrate Microsoft Defender for Cloud alerts into your security information and event management solution with Microsoft Sentinel. And also you integrate the Azure logs with your SIEM solution as well. Then we have to monitor end-to-end scenario-based networking monitoring. Here you automate remote network monitoring with packet capture. You can monitor and diagnose networking issue without logging into your virtual machine. We can leverage the Azure Network Watcher. This tool can help you insight into network traffic by using flow logs and to diagnose, for example, VPN connectivity issues. So Azure Network Watcher is your tool in the Azure cloud. Then we have, of course, the Azure AD provide risk reports to make sure to monitor for suspicious actions related to your user accounts. Last, we need to make sure to check the security operations section in the Microsoft reference architectures that I discussed earlier, which describes how Microsoft security capabilities integrate with Microsoft services and application for your Microsoft security operations function. Now moving to threat intelligence. To help you on this, you could leverage the threat intelligence from different Microsoft security solutions. We have threat intelligence TI in Microsoft Sentinel. We can integrate threat intelligence into Microsoft Sentinel by enabling data connectors to different TI platforms and feeds. You can view and manage the imported TI in logs, and the Microsoft Sentinel has a dedicated threat intelligence page. You can detect threats and generate security alerts and incidents using the built-in analytic rule templates based on your imported TI. You can also visualize key information about your imported threat intelligence in Microsoft Sentinel using the Threat Intelligence Workbook. Threat indicators are data that associate observed, such as artifacts, such as URL, file hashes, or IP addresses, with non-threat activities such as phishing, botnets, or malware. So those all are, you can see them through the threat intelligence feed that you import to Sentinel. With Defender for Endpoint, we can also create custom threat alerts that help you track of possible attack activities in your organization. And alert definitions are contextual attribute that can be used to collect and identify early clues on a possible cybersecurity attack. IOCs, indicator of compromise, are actually individually known malicious events that indicate that a network or a device has already been breached. So also TI is available in Defender for Endpoint. We have also TI in Defender for Cloud. But this is included by default. You don't need to import anything here like in Microsoft Sentinel. When Defender for Cloud identifies a threat, it triggers a security alert containing detailed information regarding the event, including suggestions for remediation. And to help incident response team investigate and remediate threats, Defender for Cloud provides threat intelligence reports containing information about detected threats. And the report, which is a PDF report that you get from the alert, include information about attackers' identities or associations behind attacker objectives, the tactics that attackers used, tools and procedures, if any associated IOCs, such as URLs and file hashes, and the mitigation and the remediation information, and much more. So this is built in already in the Defender for Cloud. Next, we have threat investigation and response in the Microsoft 365 Defender portal, security.microsoft.com, where it has a set of tools and response workflows that includes Explorer, incidents, attack simulation training, automated investigation and response. The TI and response activities provide insight into threats and related response action available all in the Microsoft 365 Defender. These insights can help your security team to protect users from email or file-based attacks. So this is on the Microsoft 365 side. So don't confuse it. Defender for Cloud is for Azure, and on-premises multi-cloud, and Microsoft 365 Defender for the Microsoft 365 services. Now, on the best practices side, Microsoft recommends different ways to use threat intelligence feeds to enhance your security analyst ability to detect and to prioritize known threats. We can use one of many available integrated threat intelligence platform products. You can connect to taxi servers to take advantage of any STIX compatible threat intelligence source. And you can also make use of any custom solution that can communicate directly with the Microsoft Graph security APIs. Now, for those who don't know what taxi is, there is actually an organization called Oasis who has created something called STIX taxi. STIX actually is a schema where they have developed for sharing the TI data, and taxi is a protocol over which threat intelligence is shared. We can also connect to threat intelligence sources from playbooks to enrich incidents with TI information to help direct investigation and response actions. This is STIX taxi which is available in Sentinel as well to integrate. All right, before we move to the last objective in the first module, let me see, take a quick pause here to see if we have questions. We have a question. Okay. Arc, you need to install the Arc agent, and then there is extension that will be enabled by default. So it's only one agent, and then which, for example, Defender for Endpoint, you can use on premises, which can integrate with the agent of Arc and to enable that feature. This agent is required for Azure Arc. What we have? Does the exam deal with software and DevOps? Yes, we can see later when we reach to the application section. Yes, we see what actually security tool we can use to deal with containers, images, Kubernetes, what tools. Yes, but not dev code. We give us the tools for the application developers that can use. Yes. But of course, you will not get code, any technical thing, but you need to know the solution that you can use to scan for any malicious code and need to scan also container images and Kubernetes. Next question. Hi, if we don't leverage Defender suites, how can we still concrete these products? Defender for suites, you mean if you don't use any Defender for suites, so it's not understand the exact questions, because we have now Microsoft renamed all the Microsoft products, all of them are called Microsoft Defender X, Microsoft Defender, Sentinel, Defender for Cloud. So we have on the Azure side, multi-cloud side, and we have on the Microsoft 365 Defender. So here, about the exam, yes, we need to know all the Microsoft Defender for suite for any type. So they want to know if you know the products behind any scenario or any technical requirement and security requirement, which the appropriate Defender scenario, product solution you need to use here. All right, let's move now to the last objective. Let's move now, this is last objective of the first module, design and identity security strategy. Again, this section is very, very important on the exam. Identity. That's I got the question before why you recommend the SC-100 exam, because you will see identity is everywhere. And the first topic is about secure access to cloud resources. Because the cloud applications and the mobile workforce have redefined the security perimeter. As we all have seen, this increased during the pandemic, the last couple of years, and of course will continue. So employees are bringing their own devices, working remotely and so on, and data is accessed outside of the corporate network and shared with external partners and vendors. Now, before organizations start the zero trust journey, their approach to identity is problematic in that the on-premises identity provider is in use. We have already Active Directory in use. No single sign-on is present between the cloud and the on-premise application, and the visibility into identity risk is very limited. So when you're implementing an end-to-end zero trust framework for identity, Microsoft recommends focusing first on the initial left side, deployment objectives. We have on the left side, the cloud identity federates with on-premises identity systems. Here we connect all our users to Azure AD and federate with on-premises identity systems. You establish identity foundation with Azure AD, and you integrate all your application with Azure AD. And finally, you verify explicitly with strong authentication like MFA. Next, we have conditional access policies, which gate access and provide remediation activities. Now, Azure AD conditional access analyzes signals such as user, device, location to automate decisions and enforce your organization access policy for the resource. You can use conditional access policies to apply access control like multi-factor authentication. You can enforce it with conditional access based on risk factors and sign-in locations. Next, we have analytics to improve visibility. As you build your estate in Azure AD with authentication, authorization, and provisioning, it's important to have a strong operational insight into what is happening in the directory. So you need to configure logging and reporting to improve visibility. After the initial three objectives are completed, next you focus on the additional objectives for more robust identity governance. So on the right side, we have identities and access privileges, which are managed with identity governance. Here you use secure privilege access with privilege identity management PIM to restrict user consent to applications. You manage the entitlement and user passwordless authentication to reduce the risk of phishing and password attacks. There is a module in Azure AD for identity governance that covers all of these. We'll talk more about this the next few slides. You need Azure AD P2 license for the identity governance. Remember this. Next, we have the user's devices, location, and behavior are analyzed in real time to determine risk and deliver ongoing protection. Real-time analysis is critical for determining risk and protection. You deploy Azure AD password protection, and you enable identity protection. Then you enable Microsoft Defender for Cloud Apps, the CASB that I talk about, integration with identity protection, which can be integrated with conditional access as well. And finally, you integrate threat signals from other security solutions to improve detection, protection, and response. For example, integration with Microsoft Defender for Identity, MDI, it's called acronym, enables Azure AD to know that a user is indulging in risky behavior while accessing on-premises, non-cloud resource, like, for example, file server, file share. We talk about later Microsoft Defender for Identity is on-premises solution that captures signals from your Active Directory services. This can then be enforced to get the signals. If the user have risky behavior, for example, you can enforce based on the user risk. You can take a decision to block further access in the cloud if there is any risky behavior on premises. Next, you need to choose the correct authentication and authorization methods. This is also very important for a couple of reasons. Because it's first decision you want to take when you decide to move application to the cloud. The authentication method is a critical component here. It controls access to all cloud data and resources. And it's the foundation of all the other advanced security and user experience features in Azure AD. So when we use the Azure AD hybrid identity solution as your new control plane, authentication is the foundation of cloud access. Because choosing the correct authentication method is a crucial first decision when you set up your Azure AD hybrid identity solution. Here you implement the authentication method configured by using Azure AD Connect, which also provisions users in the clouds. And now to choose on the authentication method, you need to consider the time, existing infrastructure, complexity, and of course the cost of implementing your choice. Of course, these factors are different for every company, every scenario that you might get, and will change over time. And Azure AD supports cloud authentication, password hash, and password-free authentication, and also the federated authentication methods for hybrid identity solutions. Let's talk about each of these authentication methods in more details. The first one, when you choose cloud authentication method, Azure AD handles user sign-in process. Cloud authentication includes single sign-on SSO so that users can sign in into cloud apps without re-entering their credentials. With the cloud authentication, there are two options. The first one is Azure AD password hash synchronization. As shown in this diagram, this is the simplest way to enable authentication for on-premises directory object in Azure AD. And this is not the original password hash, it is the hash of the hash. So it cannot reverse it. They hash it multiple thousands of times. User can use the same username and password they use on premises without deploying any additional infrastructure. So premium features like Azure AD, identity protection, and Azure AD domain services require password hash synchronization, no matter which authentication method we choose here. So password hash synchronization requires, those are premium features for ID, identity protection, and Azure AD domain services. Next, we have the pass-through authentication. This option provides a simple password validation for Azure AD authentication services by using an agent, by using a software agent that runs on one or your on-premises servers. As shown in this diagram, the agent is required for pass-through authentication, and you need to use, of course, two agents for redundancy. The server validates the users directly with your on-premises Active Directory. This ensures that password validation doesn't happen in the cloud compared to the hash synchronization, password hash synchronization. And if you have a security requirement in your company to immediately enforce on-premises user account states, password policies, and sign-in hours, you might use this authentication method. And the last authentication method is federated authentication. In this case, Azure AD hands off the authentication process to a separate trusted authentication system when you choose a federated authentication option. An example is on-premises Active Directory Federation Services, ADFS, to validate users' password. As shown in this diagram, this authentication method requires additional component for federation in your perimeter and internal network. The authentication system here provide additional advanced authentication requirements. For example, you can use smart card-based authentication or third-party multi-factor authentication. We can use it with federated authentication. Now moving to authorization methods, authorization verifies that the identity user attempting to connect has the necessary permission to access a service, feature, function, or object. Authorizations always occurs after successful authentication. If a connection isn't authenticated, it fails before any authorization checking is performed. If authentication of a connection succeeds, a specific action might still be disallowed because the user or group did not have the authorization to perform that action. Here we use the Azure Role-Based Access Control, RBAC, which help you to manage who has access to Azure resources, what they can do with those resources, and what areas they have access to. The authorization methods listed here help you to understand and enforce zero trust. Authorization depends on the permissions assigned to the account. Permissions can be granted either directly to an account or through membership in a security group or security role. And access levels and features flag can also grant or restrict access to specific features. And security namespaces store data that determines the level of access that an account must perform a specific action on a specific resource. For example, this one is used in Azure DevOps. Please check the URL about permission for more details. Now moving to conditional access, this is also very important for zero trust as well, because conditional access helps to ensure the right user has the right access to the right resources. When we enable conditional access, we can allow Azure Active Directory to make access decisions based on computed risk and pre-configured policy. For example, let's say device is not compliant, we can enforce and make decision around that. Again, now every company might have different requirements and security policies. When you create an architecture and follow the suggested framework for conditional access from Microsoft, you need to consider the company's requirement. And in the SC-100 exam, this will be based on the case study that you will receive. The guidance that I will share with you in the next slides include principles related to zero trust that can be used as input when you create an architecture. Then you need to address specific requirements and adjust the architectures and policies accordingly. For example, in your company, you might have these requirements. At least 2 factors must protect all access, no data on unmanaged devices, all devices must be managed, no guest access is allowed, and access to cloud services must be based on passwordless authentication. Now, the Microsoft approach to Zero Trust includes conditional access as the main policy engine behind it. And conditional access is used as the policy engine for a Zero Trust architecture that covers both policy definitions and policy enforcement. As shown in this diagram, based on different signals or conditions, conditional access can block or give limited access to a resource. Now, first, you need to choose an architecture for conditional access. And Microsoft recommends that considering either a targeted one or a Zero Trust conditional access architecture. These 2 screenshots here show the corresponding conditional access settings. The Zero Trust conditional access architecture is the one that best fits the principle of Zero Trust. For example, if all cloud apps option in conditional access is selected on the right side, all endpoints are protected by the provided grant access control, like non-user and non or compliant devices. But the policy doesn't just apply to the endpoint and apps that support conditional access. It applies to any endpoint that the user interacts with. And the challenge with this one is the sign-in is that it doesn't support device-based conditional access. An example is the device login flow endpoint that uses a various new PowerShell and Microsoft Graph tools. And device login flow provides a way to allow sign-in from a device on which it's not possible to show a sign-in screen like an IoT device. This means that nobody can use the tools and commands if you apply a baseline policy requiring non-user or unknown devices for all cloud apps. The other architecture one is the targeted one on the left side, is built on the principle that you target only individual apps you want to protect in conditional access policies. Here, the challenge with this architecture is that you might forget to protect all your cloud applications because the number of Office 365 and Azure Active Directory applications increases as Microsoft and partners releases new features. And your IT administration integrates various applications with your Azure AD. So those are recommended approach. Now, how to design a conditional access personas? Now, personas are identity types that share common enterprise attributes, responsibilities, experience, objective, and access. You need to understand how enterprise assets and resources are accessed by different personas is essential to develop a comprehensive Zero Trust strategy. There are many ways to structure conditional access policies. One approach is to structure policies based on the sensitivity of the resource being accessed. In practice, this approach can be difficult to implement in a way that still protects access to resources for various users. Another approach is to define access policies based on where a user is in the organization. This approach might result in many conditional access policies that you might create and might be unmanageable. A better approach is to structure policies related to common access needs and bundle a set of access needs in a persona for a group of users who have the same needs. And Microsoft recommends defining a separate persona for identities that are part of any other, that are not part of any other persona group. So this is called the global persona. Global is meant to enforce policies for identities that are not in a persona group and policies that you should be enforced for all personas. The list here describes some recommended conditional access persona that you can use in the environment. Now, in the conditional access guidance, I have put here the 3 guidance to help you architect and structure your conditional access policy. We have the first one, the conditional access design principle and dependencies, which provides a recommended principle that together with your company requirement can serve as input to the suggested persona-based architecture. The next one, we have the conditional access architecture and persona, which introduce the persona-based approach for structuring your conditional access policies. It also provides a suggested persona to use as a starting point. And the last guidance here is conditional access framework and policies, which provides specific details on how to structure and name conditional access policies based on the persona. Please go through the guidance to learn more about the design principle and dependency for a conditional access scenario, not all of them based on the zero trust. Keep always the zero trust in your mind during the exam. Now, to move on to the next topic that we need to discuss is about security solutions that we can use to design a strategy for role assignments and delegation. This is also an important topic on the SC-100 exam. Let's take, why do we want to assign roles to groups? Let's take the following example. For example, you have a company that hired people across different countries to manage and reset passwords for employees in its Azure AD organization. Now, instead of asking for a high privilege role to assign the help desk administrator role to each person individually, you can create, for example, a help desk administrator group and assign the role to the group. So when people join the group, they are assigned the role indirectly. In this case, your existing governance workflow can then take care of the approval process and auditing of the group's membership to ensure that only legitimate users are members of the group and thus assign the help desk administrator role. So you need to leverage here the security groups and assign the member. We can see later this, we can use the privileged identity management that can help us to accomplish. Now, on the best practices for Azure AD, role assignment, and RBAC. Let's talk about these eight best practices. If you do not want members of the group to have always access to a role, we can use the Azure AD privileged identity management PIM to make a group eligible for a role, as we just discussed. Using PIM as a user can be made an eligible member of an Azure AD role, where they can then activate the role for limited time when needed, so 2 or 8 hours, for example, and then privileged access is automatically removed when the time frame expires. The next best practice is to manage to least privilege. There are 3 aspects to consider when you assign a role to your administrators: a specific set of permissions over a specific scope for a specific period of time. So by limiting roles and scopes, you limit what resources are at risk if the security principle is ever compromised. And there are built-in Azure AD roles to manage direct objects like users, groups, and application, and also to manage Microsoft 365 services like Exchange, SharePoint, and Intune. The third best practice is MFA. We all know about MFA for all admin account, and also I would rephrase that sentence. I would say MFA for all users, not only admin sensitive accounts, because based on different scenarios, we have read everywhere that your account is 99% less likely to be compromised if we use the MFA authentication. You can enable MFA on Azure AD role using 2 methods: role settings and privileged identity management, PIM, or using conditional access policy. Next, we use and configure recurring access reviews to revoke unneeded permission over time. Access reviews is an Azure AD identity governance, will help you to review administrator access regularly to make sure that only the right people have continued access. You do regular auditing of your administrator is important.